No matter how good our code is, exceptions are bound to occur. Therefore, rather than try to completely avoid exceptions, we should look to handle them effectively. Okay, here we go. So in this one, we're going to deal with Spring Boot exception handling. So first of all, we're going to set up a project, a really basic REST API, which when you hit one of its endpoints, an exception is going to be thrown. And I'm going to use that to show you 3 different ways of handling that exception in Spring Boot. Now, it's worth noting there are probably half a dozen different ways of handling an exception in Spring and Spring Boot, but I'm going to show you the 3 which I think are most valuable, and I'm going to point you in the direction of the documentation for the other ones in case you're interested. I'm going to put a timestamp on screen for you, and if you go to that timestamp, it will be us dealing with the exceptions. But to start, we're going to set up this project, which is why we're at the Spring Initializer. So the Spring Initializer is a project which is set up by Spring to allow you to generate skeleton projects for your Spring Boot applications very, very quickly. So let's go through this. The first thing that we need to do is select a dependency management tool. In this case, I'm going to select Maven. I'm going to make sure that we have Java. And we're just going to use the general release version of Spring Boot here, which is currently 3.03. Now for group, I'm going to do com-dev-tiro. And for artifact, this is just going to be a very generic REST API. So I'm just going to call it generic. Now, if we take a look at the description, I don't know, a generic REST API. And the package name of generic is absolutely fine in this case. So packaging, we're going to select jar, and we're going to select jar because jar bundles in for us a server, so a Tomcat server is the default. But if we selected war, we'd actually have to deploy that artifact to a running Tomcat server, an external one, which I don't have, and you probably don't have running either. Now, in terms of Java, we're going to select Java 17 here, which was the default selected. And for dependencies, we only really need the bare bones in order to generate a REST API. So in this case, we'll just go for Spring Web. Now, you can use Spring Reactive Web, I'm pretty sure it's called. Let's have a look. Yeah, Spring Reactive Web, which is a more modern way of doing things. But chances are, if you're dealing with these applications in the wild, they may well be using this one, which is a long-standing one, which is, like I say, using the embedded Tomcat server. Oh, there it is. It mentions it there. So let's go ahead and download this one. Okay, and let's open this up inside of Visual Code Studio. So here we are in Visual Code Studio, and this is a very basic project, as you can see. We've just got the entry point on screen at the moment, which is just the generic application main method. And we could go ahead and run this right now if we wanted to, but we're not going to because it generally does nothing right now. So let's get started. And the first thing that we're going to do is create for us a custom exception, which will then handle with the various different methods. So what I'm going to do is inside of the kind of root package of our project, let's create a new folder in here, and let's call this one exceptions. Inside of exceptions, I'm going to create a new file, and I'm going to call this one custom exception.java. And I'm going to choose to extend here the runtime exception. And the runtime exception is different from the normal exception in the case that it's unchecked. So checked versus checked exceptions. If I was to extend exception, then the compiler would check that I'm handling it every time that I'm throwing it. It's a checked exception. Runtime exception, you don't need to do that. Now, there is some back and forth on which is the best one to use. If you read the clean coding book, it recommends that you use runtime exception in most cases. I'm going to use it today because it's going to make me showing you how to handle these exceptions a little bit easier, and you'll see why later. So we need to now just do some basic overriding of constructors or implementing of constructors, and you can do that in Visual Code Studio with the source action. And let's generate our constructors. Okay, we'll have that one, that one, that one, and that one. Okay, and easy as that, we now have a custom exception which extends runtime exception. So now let's create a service which throws this exception, shall we? And we can do that by creating a new folder in here, and I'm going to call this one services. And inside of services, I'm going to create a new file, and I'm going to call this one risky service.java. There we go. And risky service.java is going to have a single public method, and it's not going to return anything, but it is going to throw an exception. And I'm going to call it, let's call it take risk. And if custom exception was a checked exception, this is where I'd have to declare it in the method signature, but I don't have to as it's a runtime exception. Okay, and I'm now going to, in the implementation of this method, do one thing and one thing only, which is throw the exception. So throw custom exception. And let's just give it a message. Something has gone horribly wrong. There we go. We just need to import this. Oh, no new keyword. There we go. that is our service. We have just done it as a class. Now, just while we're here, I suppose you always want to code to interfaces, never to the concrete classes. We could technically get away with this as it's a tutorial, but to be honest, it's so easy to extract an interface that we might as well do it now. So let's first of all rename this class, shall we? Which we can do if we scroll down a little bit. And I'm going to call this risky service impl. And now using some refactoring magic, which is not in that list. Okay. And we're now going to refactor, extract interface at the top here. We now want to say, let's use take risk in that interface. And we're going to call it risky service. And let's place it in services, why not? So we can now see that there is an interface risky service with a single method. And we have here an implementation for that risky service, which simply throws custom exception every single time. So we now have a service that we can use to throw an exception, but we do just need to put an annotation on top of this class, which is at service, which tells Spring that, hey, this is a service and you should inject this where it's being asked for. Now then, let's create a very basic controller, shall we? So we'll create a new folder in here and we'll call it controllers. And inside of controllers, I'm going to create a new file and I'm going to call this one risky controller.java. And this is going to be a REST controller. Now let's set a path for this, which you can do like so with a request mapping. Perfect. And this is simply going to be /risks in order to call this controller. And now we need to do an endpoint. And we're just going to do a straightforward get endpoint. So get mapping. And we'll do a public response entity. And we'll just say get risk is the endpoint here. Okay, and what are we going to do in the get risk implementation? Well, we need to return a response entity. We know that much. So let's say return new response entity. And the status for this one can be http status.ok. Okay, so if we were to hit this endpoint, we would just get a blank body and the HTTP status code OK. But that's not going to demonstrate any exceptions. So we need to throw an exception. So let's get hold of our service, which we can do with private final, and it was called risky service. Okay, so we've made this final as is best practice to mean that it can't be reassigned after it's initialized. Now we need to set this, which we can do via the constructor, which I can auto generate for us, which is handy. And then we need to put the @auto wired annotation on the top of it, and that tells Spring, hey, we need a risky service here. Can you inject one? Yes, because we've already put the @service annotation on it, so it exists. So then it gets assigned to this local instance variable here for our use. I'm just going to put a final in front of that. Let's call it in here. So risky service dot, and it was, what was the name of it? It was take risk. That was right. Okay, perfect. So that should, in theory, be everything that we need to do. So if we start this application up now, we should be able to hit this endpoint and take a risk, I suppose, and see the exception that's being displayed for us. So I'm going to do that via Postman. So before we can do that, though, let's start the application, which I'm going to do via the terminal here. And I'm going to call the Maven wrapper, which is bundled in. So there it is. Spring Boot, run. And that's going to run our application for us. Okay, start a generic application, and it is running. Okay, away we go. Let's go over to Postman. Okay, so here we are in Postman, and we can see here that we've got the HTTP get verb, and we also have the path, which is /risks. So this matches what we set up in our controller. So let's go ahead and click on send, and we should expect a HTTP 500 more or less, and it should tell us the details of the exception being thrown. Now we have a 404 not found, and I think I know why. Let's go back over to our code. Should be an easy enough fix. Yeah, we're in the wrong directory. So in order for Spring to pick everything up, it must be inside of the root project directory, which of course is generic here, but I have mistakenly put this in the com.dev.tiro. So let's move everything across. Okay, so now everything's in the correct directory, which is generic. Let's rerun our application. So we're going to go Maven Spring Boot run. There we go. Our application's up and running. Let's flip back to Postman and let's hit that same endpoint, shall we? Okay, we have a 500 internal server error now, which is actually what we're expecting. So this is a good thing. Now let's take a look at the details that's returned to us. So we can see here we've got a timestamp, the status, which is 500, and the error, which is the internal server error for the path risks. Now, if we take a look at the stack trace, which exists inside of our running terminal here, we can see here, there's our exception being thrown, there's our custom exception, and there's our message that something has gone horribly wrong. Oh no. So, how do we deal with this? And the first way that I'm going to show you is perhaps the simplest, but not the most scalable. And that's by doing a good old-fashioned try-catch. Now, if we try, and inside of the try block, we're going to do the risky service take risk, which throws the exception. And I'm going to catch the custom exception that is being thrown. And now we can choose to handle it in some way. So one way to handle this is by throwing an exception again, but one that Spring knows how to handle. And it's called the response status exception. So if I were to throw a new response status exception, I can now control the HTTP code that's going to be used. So in the case at the moment, it's HTTP 500, which is an internal server error, but I then have the ability to change that, which I could change to, let's have a look, HTTP status dot any of these. So we're going to change it to I am a teapot, because there is no chance that that's going to come up accidentally. We're essentially here doing a good old-fashioned try-catch block for the exception that take risk is throwing, and we are going to rethrow an exception, which is the response status exception, which allows us to tell Spring what the HTTP status should be on the response. So let's go ahead and rerun this application, shall we? There we go. There's it up and running. So let's flip over back to Postman here. Okay, and this is the same, exactly the same. So we're going to just click on send here, scroll down, and there we go. HTTP status 41A, I am a teapot. And we can see here the status 41A in this generic exception response. Now, that's the first way of handling it. There are some limitations though, which is we have to do the try-catch block every single time that an exception is going to be thrown. And if there's different types of exceptions which could be thrown from this, we need to do multiple catch blocks. The second one is that actually this doesn't really give us a lot. I mean, the response status exception is really cool and it allows us to control the status, but we might want to do something a little bit more refined. So I'm now going to show you option number 2. So let's get rid of this try-catch block and then just rerun the application to get us back to where we were before. Redo this request, and we have a 500 internal server error, and there is the response body. If you found this useful so far, be sure to hit that subscribe button so you can see more videos just like this. Okay, so the second way of dealing with this is by using an annotation inside of the same controller, and that one is the exception handler. And this is put on top of just a normal public method here, and it's going to return a response entity. And I'm going to call this one handle custom exception, which takes an argument, which is a custom exception. There we go. So the implementation of this method is quite cool because we take a custom exception and then we have to turn that into a response entity, which of course allows us to control everything. So I'm going to return a new response entity. Oops. And I'm going to pass a HTTP status code of OK, let's say. And that would just return a blank body, which is OK. But let's say I wanted to return something different. Let's just say a string body of no risks here. Oh, and then in the exception handler annotation, the one thing that we need to do is tell it which exception that we are dealing with here, which in this case is going to be the custom exception.class. So in summary then, every time a custom exception is thrown inside of this controller, this exception handler method is going to be triggered, passing in that same custom exception, and then we're going to go ahead and return this response entity. So let's go ahead and test this, shall we? And the way that we can do that is by rerunning the application. Okay, we're up and running, so we are expecting a HTTP 200 and the string response body now. Click send. What do we got? HTTP 200, very good. And no risks here. String response body. Okay, so that's the second one. This is obviously a lot better. It's a lot more flexible because you have that response entity that you can deal with here, which is great. Now, the limitations of this approach is it has to be done in every single controller, right? So you need to do an exception handler in every single controller. And if you have the risky service being used in, let's say, 3 different controllers, for example, that's 3 different places that you'll need to do this exception handler. Or the alternative is that you would have a base class, a super class of the classes that then use the risky service. which has the exception handler annotation in it. And that's the way that we did things traditionally. However, that's not great because it means that you then need to extend that class every single time you use the risky entity, and that's that's more coupled than what I'd be comfortable with. So there has been a new way of doing things recently, which is basically a separate class to have all of the exception handlers in it, which we typically call a global exception handler. And I'm going to show you that approach now. But instead of deleting this, I'm just going to cut that. Go. And let's just get back to that error state again, which I'm going to just restart the application. Okay, we're up and running. Give me a HTTP 500, please. There we go. 500 status. Yeah, perfect. Okay, back to error status. Now, let's go back over here. Now, I'm going to put this in controllers, and I create a new file, and I'm going to call this one global exception handler.java. All right, so there's our global exception handler class doing absolutely nothing. So the magic annotation that we need is controller advice, not controller advice. There we go. Okay, and now if we were to paste in our exception handler from our other class, let's just import these because they are not imported. This exception handler now, as it's in the global exception handler class, which has the controller advice annotation, would be used every single time that this custom exception is thrown and bubbles up to the Spring framework, which obviously is great because it allows you to set the conventions for your entire web app in one place, and you don't have to extend it. So you still have the option to use inheritance in your controllers if that's something that you wanted to do. So this is pretty much the same thing, but I want it to return something different, which is let's say defo no risks here, and HTTP status. What else we got? Let's do teapot. Let's do teapot. There we go. So that's very different from what we had before, sort of. Okay, so let's go ahead and run this now. Okay, we're up and running. Let's flip back over to Postman. Click on send. We have 418, I am a teapot, and we have the response body, we have the response body defo no risks here. In a nutshell, that would be the one that I'd recommend for you. It allows you to put all of your exception handling stuff in one place, and it allows you to have then those conventions used throughout the application. Of course, if you did want to override this at any point, you could use the first method in addition, which would allow you to catch the exception before it got to the global exception handler, and you can do your own little custom logic in there if you wanted to. But in a nutshell, there are the 3 different ways that I would recommend of handling exceptions in Spring Boot. And there you have it, the 3 ways that I would recommend that you do exception handling inside of Spring Boot. Now, if you found this interesting and you want to see more about the Spring Boot ecosystem, then be sure to check out this video, which teaches you how to use Kafka with Spring Boot. I'll see you over there.